So let's not forget about you. And we will start. Hello and welcome everybody to the 4:30 session of Track A. I would like to first of all thank our gold sponsors for today, Amdocs and Checkmarks. You can learn more about them and about their contribution on the conference website at the EPSIC-IL website. The talk now is going to be by Or of application. She's an application security researcher from Checkmarks, our gold sponsor. The topic of the talk today is tag soup, food for mXSS. So it sounds like a pretty delicious session to have coming along. And Or, all yours.
Okay, you can see my screen? Can you
Yes,
see my screen?
Yes,
Okay. Okay. So, hi everyone. Welcome to the talk about tag soup, food from Mutation XSS. So to cut things short, once upon a time I was a developer, now I'm not. The extended version is that back on 2007, I was the MSNIL search engine and communities development team lead. We got an email from Microsoft that a group of white hats succeeded to find some XSS in MSNIL search engine. So they also told us that if we'll not find a solution within 48 hours, the search engine will be closed and 30 guys from the sales department would lose their job. So I was very scared. By the way, I'm still scared from sales engineers. After I finished, I felt like it will be much more fun to find the vulnerabilities and exploit vulnerabilities than to fix those. So it took me a while, like family issues, little children, lack of confidence. But now I can say that once upon a time I was a developer. Now I'm not. So the inspiration for this talk was the CVEs that Yaniv Nizri from Checkmarks found in Mozilla Bleach. When one finds a vulnerability in a website, it's fun. It's a great fun. But when one finds a vulnerability in a popular library, the impact is much more significant. I've researched the root cause of these vulnerabilities and was curious to look for the same flaws in other commonly used libraries. We learn about Mozilla Bleach and others during this talk. But in order to understand those vulnerabilities, we need to figure out what is tag soup, what is tag soup parser, what sanitizers do in this game, how they cause the mutation XSS. And then we will be able to learn about the real-world examples. So it will be very helpful if you've heard before about HTML, CSS, and XSS. So let's make a quick refresh about XSS. I know that most of you know what is XSS, but really, really short. XSS is cross-site scripting. It happens when user input contains script instead of markups. And then the script runs in the browser. In this example, it's reflected XSS. We have a search page. The users submit search term. There is a GET request to the same page along with the search term as query string param. And then the query string param is reflected near the search engine results. A malicious user will send the link with the query string param to the victim. And when the victim reaches to the page, the script runs. So I must say something really small, but when the first time I saw an alert in a penetration tester report, I asked, who cares about this alert? So you probably know that for the demonstration, it's very easy to use alert function, but as a matter of fact, in real-world samples, we use a one-liner with some, for example, XML HTTP object and send request and do some damage. But for the demonstration, it's easy to use an alert. We usually speak about, in addition to the reflected XSS, we talk about stored XSS, and it happens when application displays user input from a database or from file or some other repositories. Like many others, this blog contains comment. Bob inserts a comment with a script, and when other users reach Alice's blog, the script runs. So as a remediation, we use sanitizers and purifiers to encode or strip potentially malicious input. When a sanitizer is implemented in Alice's blog, Bob's malicious content is encoded, and the browser interprets it as text and not as HTML. While we need the sanitizers to protect ourselves from XSS, they might expose us to Mutation Xss if the parsing process is not implemented properly. So, to cook Mutation Xss with broad impact, we need 3 ingredients. We need TAC-soup, we need TAC-soup parser, and we need a sanitizer. There are Mutation Xss with only the first ingredient, only TAC-soup. We'll see an example of such a case as well. So, what is a TAC-soup? Malformed or wrong nested HTML tag. For example, we have this opening div tag. Inside the opening div tag, we have opening span tag, and then closing div tag and closing span tag. So you can see those closing tags are switched. So this is the first example of a TAC-soup. Another example, here we have a p tag. Inside the p tag, we have a style tag. Could work, and then inside the style tag, instead of CSS, we have markup. We have HTML tag. So it looks like TAC-soup is very common. There are many websites which contain malformed HTML content. The reason might be the extensive use of what you see is what you get editor, or you could say what you see is not what you get editor, which allow user to contribute HTML content. Another reason might be the broad use of CMS. A bug in one CMS impacts lots and lots of websites. So, if I am a browser developer, like many developers, I can say, oh no, this is a wrong syntax. This is bad HTML code. I don't allow this website in my browser. So I could take this attitude, but if the popular websites contain wrong nested HTML and the other browser will support those websites, my users will leave me to some other browser, so I can't take this attitude. So the browser developer tried to guess the intention of the malformed HTML code. In the beginning, different browsers interpreted the same malformed HTML code differently. So one could see the same web page in different forms. Later, the HTML5 standard came with a TAC-soup parser algorithm. And nowadays, the major browsers follow the standard, and the malformed HTML code looks like the same in all of this. So let's take a look at the tag parser. So here we have a p tag, and inside the p tag we have a soup of, and then em tag, and HTML in capital letters, closing p tag, closing em tag. So very simple, the TAC-soup parser will switch between those closing tags. And We can see it in the browsers. A soup of HTML, HTML in capital letters is emphasized, and it works very good. So second example, here we have a code, a soup of, and then inside the p tag, we have a style element, and inside the style element, we have HTML in capital letters, a closing p tag, and the tag parser adds a closing p tag, another closing p tag. So why it happens? Because the tag parser interprets the HTML in capital letters along with the closing p tags as CSS. And that's why, if you can see it in the browser, how it's rendered, we can see a soup of, and oops, the HTML in capital letters is not there. Why? Because the HTML in capital letters is not markup and not text. The HTML in capital letters is CSS. So we saw the tag soup. We know that the sanitizers check the input as it is. If we have a query string param, the sanitizer will check the content of the query string param and send it back to the browser. Then in the browser, there will be a mutation if the HTML code is not the syntax of the HTML code is not correct. But what will happen after the tag parser? Nothing. Like if after the mutation, the HTML code is malicious, nobody will know about it. So let's take a look. Here we have a payload with no script tag. No script is an element that is displayed when JavaScript is disabled in the browser. There are two ways to look at this payload. The first one is to take the style element, and by the way, the first attitude is the attitude of the tag parser. So the first attitude is to take the style element as no script content, the image tag as markup, and then the closing style tag and the second closing no script tag are excessive. And that's why the tag parser strips the closing style tag and the closing no script tag. But there is another way to interpret this payload. And the other way is to consider the style as child element of no script, and the first closing no script tag along with the image tag as CSS. Okay, so because the tag parser took the first attitude, we have an alert again, because this again, the style, the opening style tag is not markup, it's just text for a no script element. Let's take another example. Here we have a style tag, and inside the style tag, this is really strange. We have HTML A tag, and then we have ID attribute of the A tag, and okay, total mess. So does the browser interpret the content after the opening tag as CSS? Or is the quoted string the content of the ID attribute? What's going on here? So one could interpret this code in few ways. The tag parser interprets the HTML tag along with the ID equal quote as CSS. Then the closing style tag closes the style element, and again we have the image tag open for destruction. So now that we know what is tag soup and tag parser, let's take a look at Mozilla Bleach. Bleach is a loud list based HTML sanitizing library that escapes or strips markup. There are hundreds of thousands downloads per day, million per week, few dozen of dependent repositories. A flow in such a library has significant impact because of its dependence. Yaniv Nizri found two vulnerabilities in the library. Let's dive into the root cause of this. So first of all, a simple payload. If we call Bleach.Clean with an image tag with malicious event handler, the whole thing will be encoded. So this is fine. Tag parser does not make any changes. We're good to go. But when calling Bleach.Clean sanitizing method with HTML code that contains no script tag and text tag as style, there is an exposure to a Mutation XSS. So if we take this call, it looks familiar, isn't it? we take this payload with the no script and style, and then the output, okay, this is interesting. The output will be the same payload, but Mozilla Bleach adds a closing style tag and a closing no script tag. And why is that? Because if we talk about two attitude before, the Bleach.Clean took the attitude that whatever is inside the style element is CSS. So style is inside, there is no script element. Inside the no script element, we have a style element, and whatever is in between the first, the opening style tag and the closing style tag is CSS. But the tag parser, as we've already learned, take the other attitude. So the tag parser strips the closing style tag and the closing no script tag. So again, you know the answer. We have an XSS, Mutation XSS. So the cause of this vulnerability is, in this piece of code, we can see the scripting parameter inside the underscore parse method in the Bleach HTML parser. And when the scripting is set to false, the no script tag content is processed as HTML later in this function. So we can see if the scripting parameter is false, this function start tag no script. By the way, which is the only place in Bleach.code that use this scripting member. So if the scripting is set to false, the content of the tag is interpreted as HTML, and that's why the payload works not as text, a raw text, but as HTML, along with the malicious event handler. And obviously, when scripting is set to true, the no script tag content is processed as text, as you can see here. So the vulnerability was fixed. But again, so you can see after the fix that whatever is inside the style element is encoded. It's inside the no script element, and the div is empty because JavaScript is enabled in my browser, and there is no content in the div for JavaScript enabled browsers. But so we fixed the vulnerability with the no script element. But what if we call to Bleach.Clean with HTML that contains something else? For example, maybe we will put the style tag inside an SVG or a mat tag. So, you curious? Okay, so the output of Bleach.Clean will be, as expected, we saw before this attitude. Whatever is inside the style tag is CSS. So it's fine. Whatever is inside the style tag is not malicious. But the tag parser, oh no, takes another attitude. It actually closes the style element, closes the SVG element, and then again, we have the malicious image tag along with the event handler. So in this case, there is a member escape_rc data. Actually, the member is in the superclass that the Bleach parser inherits. And when this escape_rc data member is set to false, the element after SVG is not encoded. So Bleach parser did not set the escape, the original code did not set the escape_rc data at all. So the value that was set in the superclass was inherited by Bleach. So if the escape_rc data is false, the in_c data variable is set to true, and then this piece of code, the upper piece of code, happens after the bottom one, because it's a for loop that parse every token that's in the HTML code. So it looks like fine because we have self dot encode and then the data. So it looks okay. Encoding is fine. We like encoding, isn't it? But if you continue debugging, you see that in this case, the encode method does nothing for us. So it takes the input string and returns the input string, and nothing is escaped and nothing is encoded. So obviously the fix, again, is setting escape_rc data to true. And when escape_rc data is set to true, the element after the SVG is escaped. Okay, there is an error in the slide. Okay, so it's escaped. The encode does nothing as before, but we have the escape method that escaped the data for us. So I was curious to check out what will happen if I take the first vulnerability, cancel the first fix, and implement only the second. And it was also it also worked. So you will see it in the next slide. But here you can see the content. The content of the style tag is encoded. We see nothing because there is no content on the SVG element. And as I said, also in the first payload that we saw, I canceled the first fix, implemented only the second, and it works just fine. So after this research, I thought to myself that if one makes some mistakes, probably others will make the same mistakes too. So I was looking for a popular sanitizing library, and I found Sanitize-html with close to 850,000 downloads per week, and I start to figure out what's going on there. So first of all, a working payload, we see SVG with a malicious event handler. And then it works like fine. The output is empty SVG tag, basically. So in this case, it's okay. But what if we'll take this strange payload, which is basically a text area, and inside the text area, we have something like, looks like encoded closing text area tag, SVG tag with malicious event handler. So the output is surprising. Thank you very much, Sanitize-html. You help us a lot because the Sanitize-html took the escaped version of the payload and actually changes it to something that could work not so bad. So the text parser only cancels the closing text area, adds a closing SVG tag, and again, we have the famous pop-up. So the cause of this vulnerability is that a content after a text area start tag is not escaped. Why is that? Because you can see there is a non-text tags array, and inside the non-text tags array, there is text area. And and in the parsing process, when text area of one or another member from the non-text tags array is detected, whatever is inside, whatever follows this start tag is not escaped. So the fix was very simple. Instead of using this tags array, they just check if the tag that is parsed is not script and not style, and if it's not script and not style, the content is escaped. By the way, script is obvious, because if you use script, there is nothing we can do with for you. I don't see a reason to use a sanitizer and to allow script into to this sanitizer. Why should we check script anyways? But the reason they include the style is really interesting, because once upon a time there were expression in CSS. Now it's not allowed anymore. So I think the reason they put this style in the if condition is because they don't have something that could really check CSS. So they just leave it like that. If you want to use style, find a solution. Okay, so after the fix, the output is not this one, but as much the output is quite like the same as the input. And we have all this encoded content inside the text area. We're fine. So, you know, once I've heard from developers, XSS doesn't exist anymore. We have .NET, we have encoders, we have anti-XSS, many excuses. So XSS there is no XSS vulnerabilities nowadays, but it's not true. When you do a penetration test, you know exactly that there are XSS are still alive, and Mutation Xss also exists in 2020. So the year of Corona, jQuery gave us a surprise. So HTML method and alike mutates benign input. So here we have tag soup, as I promised. We have a tag soup, but we don't have sanitizer involved, and we don't have tag soup parser involved. It's only the tag soup. So let's take a look how we use HTML method. We just grab a div tag, put HTML inside, and then we'll see in the browser the div with the HTML. Here, emphasize with red, you can see the jQuery HTML code, inserts HTML to the div, and then the output in the browser. Very simple. Now you can see the same thing with native JavaScript. Here we have again, we take the element, put the HTML, it is shown in the browser, and then the same result. Okay, but what if we take this very strange payload? jQuery HTML output will be really strange. You can see that in the input we have only one X. Let's take it simple. We see only one X, and in the output we can see 2X. So what's going on here? And what the native JavaScript output is, it looks like the native JavaScript output is the same as the input. So what the hell HTML did, the jQuery HTML did? And let's take a look. You can see it here, even in the browser, emphasized with red. Again, you can see the HTML code. Then you can see what's going on in the browser. And of course, we have the output and the promised pop-up. While in green, you can see the same activity, and the div of the native JavaScript look pretty much okay. Like the payload is inside the malicious payload is not malicious because it's a part of the title attribute. So there is no alert. So only the HTML method of JavaScript does the problem. So the cause of this problem is HTML prefilter. So when you call the jQuery HTML method, you call eventually the HTML prefilter. And this method replaces every self-close tag to an element with starting tag and closing tag. So that's why this X was muted to something with 2 X's, whereas X quad is the name of the tag. Nice. So the fix was obviously to cancel the wonderful functionality of HTML prefilter. I assume that they didn't cancel this method because there are probably many calls to this function, and they didn't want to make so many changes in jQuery. So it was simple just to cancel the functionality. And now the code is not vulnerable. Wow. So we talk about TagSoup, and the TagSoup parser is friend. We examined the role of the sanitizer in this game and how they cause Mutation Xss. And we took some real-world examples, two of TagSoup, TagSoup parser, and sanitizer, and jQuery only with the TagSoup. So I don't want to end this session without giving you food for thought. So some inspiration for pen testers, also known as make developers sad engineers. So search, it's something good to do anyway, but search for vulnerable third parties that are in use. It could be sanitizers, it could be other libraries, it could be what you see is not what you get editor. Whatever is inside, whatever you can check, look for those vulnerabilities. Try the payload from the stock. And play with TagSoup. You can prepare a simple HTML page and just scramble some malform HTML tags and look how it works. And please find more malicious payloads and share with me. Some inspiration for developers, also known as bugs engineers, sorry. Or the other ones called SOX engineers. Before using a third-party sanitizer, what you see is what you get editor, what you see is not what you get editor, or any other component. Make sure it's not vulnerable. You can just Google it. Google the name of the component with vulnerabilities word, and you can find a lot of information. Make sure, this is also for DevOps. There are many DevOps engineers nowadays. Make sure you have an easy way to update a component if a vulnerability will be found. And use a sanitizer that considers the TagSoup parser activity. So the solution is really simple. If you know what the TagSoup parser does, just imitate the same functionality in the sanitizer. So if a sanitizer does it before the TagSoup parser, there are no surprises. And read the HTML substandard without falling asleep. I really tried. If you do it, you are an hero. So thank you very much for listening. You can ask me questions. I'm pretty excited, so I'm not sure that I can really be focused enough to answer a question right now. But please feel free to contact me via LinkedIn, Twitter, or email, whatever is comfortable for you. So thank you very much. Take care, stay safe, and thank you very much for my team, for being awesome. Bye, guys.
Thank you all very much for the I learned a lot from this talk. The whole Mutation XSS is pretty fascinating to me. I hope it was to everyone else as well. As Or said, if you have questions, don't put them in the QA. Write down her email address, securelight@gmail.com, and contact her online. So thank you very much.
Bye.
Bye-bye.